and welcome back to another episode of Astro Live. And today, what we're going to be looking at is actually a really cool new provider that's coming out. So this is actually a beta provider, but it will be out soon. You can access it right now by just downloading the wheel file from a link within this document. And I've also put the link to this page in our docs in the description below. And so if you're not familiar with what Weaviate is, it is an open source vector database which stores dimensional embeddings of objects like text, images, audio, video. And what embeddings are basically, you can think of them almost like a condensed version of the content of text and any of those sources. So instead of the computer, when I'm trying to train an ML model, need to read in a whole sentence, it can read in something, a vector that represents that sentence as just a single object rather than 7 different words strung together. So if you want to follow along today, what I'm going to be doing is basically showing you how to set up a local Weaviate database alongside your Airflow environment, and then connect that Weaviate database, use it to generate some embeddings from some movie descriptions, and then we're going to use those embeddings to train an ML model that will predict good movies for us to watch based on what kind of movies we already like. And this is all going to happen within Airflow. So now I will kick it over into my VS Code local environment and show you how you can set this up from scratch. So if you want to follow along and just download the repo, totally up to you. You can do that, or you can kind of follow along and build it yourself if you're more interested in just knowing how to set up Weaviate in general. So without further ado, first thing we're going to need to do, as we do with almost all of our new providers, is I'm going to set up a dedicated new repo for this. So cd in a desktop, and then create a new directory. So Weaviate live, cd in there, and then run astro dev init. Then once I have done that, it is going to pull in all my necessary files to run Airflow. So if I go over to my desktop, Weaviate live here, we then also we'll need to download that wheel file I mentioned earlier. So if you're following along, just download it from the link in the documents. I've already downloaded it, so I'm just going to add it from my downloads folder into here. So add it into your include directory. That will allow it to be installed alongside your Airflow environment. So it's just going to show up as like binary that isn't readable because it isn't readable. It's just binary computer code. Then what we're also going to need to do that is a little unique is also, sorry, lost my here, going to need to update our Docker file as well to import that wheel file. So here within our Docker file, and make sure actually you add this line at the top. So here, instead of just adding the from Quay, add this hashtag syntax equals Quay Astronomer Airflow extensions. And this actually allows us to use some of these things like copy that aren't typically available within Docker file, but the Astronomer team has made them available kind of just as like macros almost for your Docker file. Another example is just like creating a Python virtual environment just by typing in pyenv version of Python name, and it'll create one without needing to create that all through bash. So after we've done that, we're going to include this or copy it into our installation from our include directory. We're also going to need to add it to our requirements file. Save the Docker file, save the requirements file, so just reference that wheel like you would, or similarly to how you would reference a normal provider package. And so after we're done with that, what we're going to need to do is add a Docker Compose override file to allow us to spin up a Weaviate database alongside of our Airflow environment. So Weaviate, typically you'll run in the cloud and you'll have a hosted version for for actual production, but you also have the option to spin up a local database so you can use it for testing and have a similar setup to your production. That's one of the advantages of having a Dockerized Airflow is you can spin up all these additional services alongside of it and test them without needing to connect to your production account, right? So here we'll do is new file, call it docker compose.override.yaml. Great. And then we are going to paste in this, again, just from the guide I'm following, where here, just choosing a version, Then we're bringing in a Weaviate, the latest Weaviate image, setting it up on port 8081, setting some query limits, telling it to use a text-to-vec transformers. If you have issues with this, I actually did. You can also switch this to use the transformers API. And if you look at the docs, it will tell you how to do that and go through there. So if you're running into issues, your transformers Docker image isn't spinning up, check out the node protagonist, which is the DAG. So here we're going to create a new file called query movie vectors.py. And so here is our actual sentiment analysis DAG. So here what we're doing is importing all of the imports we talked about. So the Weaviate operators, check schema and create schema, a Weaviate hook to just execute any action we want within the Weaviate database. The airflow param model. So as part of this DAG, we're also going to have a parameterized entry. So you'll see when I trigger the DAG, I can actually define, hey, these are the movies I'm looking for and how similar I want them to be to my current movie taste. Also importing that script we created earlier, the empty operator chain, just to make it easier to define relationships between our different tasks. Then we're defining some global variables up here, user, admin, connection ID, Parquet file path, text file path, schema file path, just so we don't have to type those out every time. And then you'll see in our DAG declaration here, we have our parameters. So these are the variables that we're going to take in at runtime. So here we have a movie concepts. By default, it's going to show innovation and ensemble. And then so we add, the description is, hey, what kind of movie do you want to watch today? Add one concept per line. And then this certainty threshold is, hey, how similar do you want your movie to be to your the concepts you propose? Maybe you want something that has nothing to do with innovation or ensemble. And so then what we'll do is go into query movie vectors, check schema, Weaviate check schema operator. So here what we're doing is using that Weaviate check schema operator, reading in that, or basically reading in the text from our schema file path. So reading in that JSON declaration we created earlier. If a schema that matches that already exists, move on. We have a branch file path operator here. It's going to say create schema if it doesn't exist. So if it does exist, then create schema. Otherwise, return schema exists, and then the next operator will be an empty operator just saying schema exists. So we just have another option if that already is there. So after we're done with that, we will then create our Parquet file just by reading on our text file path, outputting it to the Parquet file path we set. We'll also have our Weaviate import, where we're going to import that movie data into Weaviate using automatic Weaviate embeddings. So Weaviate has functions that will automatically create embeddings out of your text inputs. So reading that Parquet file path and then returning the data, class name, and movie ID, which is just because that's our unique identifier column. So we're importing that data into Weaviate. Then our final step is querying that instance. So taking in those parameters here, so context params, the two variables we set at runtime, and see here in our query, we're actually querying our Weaviate database in kind of a JSON style format, where we're getting a movie that is near our movie concepts with the certainty of the certainty threshold we said before, and then it's going to return us the title, year, description, as well as how close it is to our existing movie and how certain it is that we'll like it. And so you can see here that's all going to be printed out in our logs here. And then we're just going to chain it all together with the chain function. So super useful. So now that it's all set up, we can kick it over into the UI, and I can actually run this live and show you how this all works. So if I go back over into UI, fingers crossed, there we go. So here, if I hit query movie vectors, when I trigger my DAG, you see instead of just triggering, it'll actually prompt me. So I want sci-fi, and I want it to be 90% close. Or you know what? I'm feeling loose today. Let's go 10%. I only want something that's 10% close. I'm feeling like I want to branch out a little bit. So now what I can do is I have this query